In this video, we will talk about different ML algorithms used to predict the categories and find accuracy. I will demonstrate three ML algorithms used in this case, and we will compare the three algorithms in the next videos. We will talk about some of the techniques like cross-validation techniques which we use to improve the accuracy. So basically, I've used three ML algorithms here: SVC, NB, and KNN. I will not go in detail in all the three. In general, they all are supervised ML algorithms with different logic. We will talk about KNN here, which gives the highest accuracy in this example. So what is KNN? It is a supervised machine learning algorithm that can be used to solve both classification and regression problems. It is based on a basic idea that similar things exist in close proximity. It is like birds of a feather flock together. Now we go to the coding part. So I've imported all the basic libraries which are used in this particular example, and then we load all the pickle files which we have saved in the previous videos. So we have the content parsed, we have the features train, labels train, feature test, and the label test. So what basically we do is we create a classifier for KNN, and then we fit the feature train and the label train in this classifier. This is going to train the model, and now we predict the response for the data set using the features test. If you see here, we have a function called accuracy score, which predicts the accuracy of this particular model. So the accuracy in this case is 72.47%. We also use metrics like precision and recall to actually measure the model performance. So what is precision and recall? They both are used to measure the model performance. A precision score is used to measure the model performance in terms of measuring the count of true positives in the correct manner out of all the positive predictions made. However, recall is used to measure the model performance in terms of measuring the count of true positives in a correct manner out of all the actual positive values. Now, to increase the performance of this model, to increase the accuracy actually, we will be using hyperparameter tuning method. So if you see here, we try to get all the parameters which are used in this classifier. So we have different parameters here. Now hyperparameter tuning is basically tuning few of the parameters here which can actually increase or decrease the accuracy. So we'll tune the following parameters: n neighbors. This is basically number of neighbors to use by default for the queries. Now we have got two techniques: grid search CV, randomized search CV. So we are going to use grid search CV here to actually see what all the parameters can be used and what will be the correct value for those. So in this case, we are using n neighbors. So this is how we calculate like what will be the correct value of that particular n neighbors parameter. So after fitting the value of the feature train and the labels train, we get the best hyperparameter from the grid search, which is n neighbors, and the value is 1. And if you see, the mean accuracy is increased and it is now 77%. Now we'll try to do the same thing with another technique called randomized search cross validation. So we fit the values here and we see what is the correct value for n neighbors in this case. So if you see, it gives the value as 21, but the mean accuracy has reduced. So we see that the n neighbors value should be 1 to get a better accuracy. So we get the best KNN model here, which is from the grid search. Now we try to fit our training data into this model. And if you see, the training accuracy is like 99%, but the test accuracy is 83%. So it increased from 72 to 83%. Now we have a classification report which gives the value of precision recall and F1 score. We already talked about precision and recall before. F1 score is the harmonic mean of precision and recall score and is used as a metric in the scenarios where choosing either of the precision or recall score can result in compromise in terms of model giving high false positive and false negatives respectively. We can also visualize the data using the confusion matrix. Confusion matrix are useful because they give direct comparisons of values like true positives, true negatives, and false negatives. So this is an example of confusion matrix here. So we have tried to fit all the categories and all the values which you see in the diagonal, they are true positives. And the others above and below are false positives and true negatives. We'll create a dataset with model summary to compare models. So we have the model, the training set accuracy, the test set accuracy, and I have done this for all the three algorithms. And now we save the data as pickles here. In the next video, we will be comparing different models and choose the best ML model. We will also see how we feed the test data in our model and get the result. See you in the next video.